So here we have, again, a rates of change question, or essentially a exponential growth and decay question. Now, you're given some conditions. N equals 100 when t equals 0. You've got this considered because it's a modified sort of rate of decay question. Ooh, what just happened? So you have a modified rate of decay question where dn dt is a constant, in this case 0.1 times 500 minus n. So it's kind of like your Newton's law of cooling a bit. It's not dependent just on your n itself, but from the difference to a particular constant, in this case 500. So that might give you a hint of how it would behave. And it's giving you the solution. N equals 500 minus 400 e is the kt. So this question is a little bit tougher than usual, a little bit, because most of the time in part 1, when they give you a solution, they basically just say, verify the solution works, like show it works. And usually the way you do that is, okay, if n equals this, and you want dn dt to equal this, you differentiate it, like you just differentiate it and show it works. So I'm going to show that now, okay? And which is not what this question wants. But then I'm going to show you what this question does want, which is usually not requested, but can still also be done, and you are expected to know how to do it. And once we do that, the next thing is just sketch it, which should be quite okay because it's really just an exponential function. So what we know is that, I mean, they've given you all the questions. You didn't really have to sort of appropriate in any way. We know at t equals 0, n equals 100. We know that dn dt follows the law of 0.1, 500 minus n. We know that your solution is apparently 500 minus 400 e to the negative 0.1 t. And a typical question would be verify the solution. So we would basically just take your n and we would derive it. Now, what just happened here? Do you see stuff on the screen?
No, it just disappeared.
Interesting.
Maybe it's on the other page?
Yeah, I tried. You're not seeing anything at all, are you?
No.
Neither am I. So that's very interesting. We will try to stop the share and reshare. See if that fixes any glitches. So
Yeah.
that seems to have
I can see it now. Yeah.
Okay, so just so I know, like, was it working and then it just disappeared? Like, but
it just disappeared.
Okay, so technical issues appear to have been worked out. So here we've got, you verify a solution, and the typical way you verify your solution is to just, well, derive. So we would derive the solution they've given us. And the derivative of 500 is, well, 0. You've got negative 400 times the derivative of e to the negative 0.1 is going to be negative 0.1 times e to the negative 0.1t, just using our chain rule. Now, we could simplify that, but that doesn't really help us here. So let us think of it as negative 0.1 times negative 400 still. I'm just going to rewrite in this order, e to the negative 0.1t. Now, our aim is to get it into this form, 0.1 times 500 minus n. So think about it. If n equals this, then 500 minus n is 500 minus 500 minus 400 e to the negative 0.1t. So 500 minus 500 is 0, minus negative 400 is positive 400 e to the negative 0.1t. So that's 500 minus n. So I'm basically just going to rearrange this and just go, okay, you know what? I'm going to take the negative and cancel them. So I'm going to get 0.1 times positive 400 e to the negative 0.1t. And if you take a look at this, that's the same thing as that. And so basically, I've now been able to say, okay, based on the fact that you've given me this equation, I've derived it validly. I've got this result, but that is literally just 0.1 times 500 minus n, which is going to fulfill my criteria. dn dt equals 0.1500 minus n. So I'm done. If I was to just verify the answer, that is what you would usually do in most questions, and that's fine. That's usually the requirement. You don't need to do much more than that usually. However, of course, this question is a tad different. This question specifically asks us to use integration to do so. So for this question, we can't do that. We actually need to solve. Now, it's not very difficult, but it's just that you normally wouldn't bother unless they make you, like I do here. So by integration, then we're going to basically say, okay, ignore the fact we know the solution, we need to actually find it. So dn dt equals 0.1 500 minus n. Now, when you're trying to solve, you need to pay attention to the right-hand side. The right-hand side is a constant times a constant minus a variable. This is your variable here. Your variable is capital N, which is some number, but importantly, this n is not a constant. This n is a variable, or more technically a function in terms of t. So you can't just integrate with respect to t and multiply by t. You need to know the function, which you don't yet know. You can't just sub it in, right? You can't cheat by assuming you know it. So what you have to do is recognize that you can't really integrate that with respect to t because you don't know the function, other than saying that it is a function. So you need to actually reciprocate this. You need to take the reciprocal of both sides. So dn dt, you flip it, you get dt dn. 1/10, flip that, give you 10. 500 minus n flips it, give you 1 over 500 minus n. And now you've got dt dn, and the right-hand side is in terms of n. You can now integrate both sides with respect to n. So that means t must equal 10 times, well, the integral of that is just going to be, well, 1 over a log ax plus b, absolute value plus c. So it's going to be negative 10 log 500 minus n plus c. As always, once you've integrated, you now need to determine your c, your integration constant. So that's when your information that's already written out becomes invaluable. When t equals 0, n equals 100. So we sub that in. So we're going to get 0 equals negative 10 log of 500 minus 100 is 400 plus c. And that very quickly gives you c equals positive 10 log of 400. So with that in mind, you're now going to get t must equal So t must equal your -10 log of 500 minus n plus 10 log of 400. You can factor out the 10, and then you'll have log of 400, which is the absolute value of 400 is 400, so it doesn't matter, minus log of 500 minus n. And then log minus log is just log of 400 over 500 minus n. Now, if you assume n is less than 500, then it will just be the same thing. And it will be. Okay. So now we've got t as a function of n, but that's not what they wanted, right? They wanted n as a function of t. So what you do now is you basically make n the subject. So t must equal 10 log 400 over 500 minus n. Just double checking that's correct. Good. So we just go, okay, so 10 over t must equal log 400 over 500 minus n. Take the exponential of both sides. Just swap the bottom and the left. So basically you'll get 500 minus n moved all across is 400 all over e to the t over 10, which you can think of as 400 e to the negative t over 10. Well, that's 500 minus n. So you just move the n across, move this across. So that means n must equal 500 minus 400 e to the negative 10 over t. And so that's what we got. And if we compare against what they wanted n equals 500 minus 400 e to the negative 0.1 t. Well, change the t over 10 to negative 0.1 t, and you've got the same answer. And that's how you do it. Okay. So you can see that this is different. We didn't assume that this was the answer. We didn't derive it and work from there. We worked it straight out from the very start. So this is kind of like the difference between if I give you a quadratic and I solve it, or what we did on the left-hand side is kind of like I'm saying, choose an answer, show me 2 works, x equals 2 works, where we just kind of just sub it in and show it works. The right-hand side is directly solving it without assuming anything. So now we want to sketch the graph of n as a function of t, showing corners of any endpoints and equations of any asymptotes. So recognizing that you're basically graphing n equals 500 minus 400 e to the negative 0.1 t, and you're really graphing this for t is greater than or equal to 0. I mean, when t equals 0, n equals 100, so we know that. Now, as t goes to infinity, then this basically goes to like negative infinity. So this goes towards 0. So basically go towards towards 500. Like basically the limit as t goes to infinity of n is, well, basically will go towards 500. So in other words, you're going to have an asymptote at 500, which I'll kind of drop there. It's not perfectly to scale, but it will do. And so basically, you're going to get something that looks along those lines. So this is t, and this is n. You've got 500 minus that, and so it will approach 500. It will start from 100, and it will increase towards 500, but never exceed that. And that's your graph of n as a function of t, and that's how you do the question.